Now the current problem that we have with HyperVoxels is that if we go back to our volumetrics window, if we hit Control F6, we have both xStream and HyperVoxels rendering as our volumetric plugins. Now this presents a problem with Lightwave because it does have trouble rendering both types of volumetrics, and what it's doing is placing our HyperVoxels over the entire scene. And no matter how we sort these, whether we put the HyperVoxels underneath the xStream plugin, it's really not going to help. So what we need to do is kind of take a look at our scene a little bit differently. But we don't really have to make any major drastic changes in order to correct this. So what we want to do right now is just kind of focus on the size of our HyperVoxels and take a look at how we can fix this problem. So what I want to do is open up our HyperVoxels window, select our main HV emitter, and we can see our particle size is 1.5 meters. Now we also have a bit of stretching along our velocity. And if we take a look in the perspective view, we can really see that stretching. And we might even need to turn that overall amount down. But what I want to do now is go over to Modeler, and we're going to take a look at how we are going to fix this problem. So now we have just a cleared object, just nothing in Modeler right now. And what we're going to do is create a sphere, and we just want to make sure that it is that 1.5 meters. So I'm just going to drag up the center of our sphere to be in between our grid, and then we can pull this out, and we just want to basically replicate the size of those HyperVoxels because we're going to be using these to render out a nice alpha that we can use to break up our scene a little bit more. Now because of the polygon count of this specific type of sphere, I'm going to hit N on the keyboard to bring up our numeric panel, and we're going to change this to a tessellated sphere. And then we can turn down the amount of segments, really depending on how much your system can handle. I'm going to change this and set it to 3. And then I can hit the spacebar, and I'm also going to hit F2 on the keyboard, which is going to center our object. Hit Q on the keyboard to find a surface name, and we can just call this HV underscore clip, and click OK. And now we have this object that we can use in order to correct this problem. So what I'm going to do is save this object out. We also want to make sure in this case that we're facing basically along the z-axis in our overall stretching, and you'll see why that's important once we get this over into layout. So now we can go up to the upper right and select Send Object to Layout, and now once we're in layout, I'm going to go to our Dynamics tab and select our effects linker, and now we can see we have our particle object as our main HV emitter, and our replace object is that HV clip sphere object we added in. And what we're essentially going to be doing is assigning those polygon spheres to all of our HyperVoxels. And then we can simulate a volumetric surface on that sphere in order to get a correct render for our alpha. And then we'll be rendering out both a back plate and a front plate with the HyperVoxels separately. Now for rotation, I'm going to select Align to Path HP, which is going to be both our heading and pitch. And because of the way we have our objects stretched, this will line them up correctly, And if our sphere was facing the other direction, where right now we had it on the z-axis, if it was on the x-axis, then they would be facing the wrong direction. So in this case, with our scene, we want to make sure they're on that z so they'll line up correctly to each of our particles. Now, all of our particles in the scene, there's a little over 6,000. And if we take a look at copy, now we're going to set the amount of spheres we need to create. Now, we don't need 6,000 because a majority of our particles are actually out of sight, and we really don't need to worry about rendering those or having anything in place. So I'm going to set our copy amount to 4,000, which will take care of all of our front sets of polys and front sets of points. And the rest of these options I'm going to leave with all of our defaults. And I'm going to click OK, and then it's going to create our 4,000 different spheres for the scene. And now we can see all of those spheres in our front polys and all of our particles, and all the back ones don't have anything on them, but of course those aren't going to be showing up. So if we switch to our camera view, and now we can scrub through the animation, we can just see all of those coming into view, and then also interacting with our trees and going through them. Another thing you'll notice is that the sphere we have is not quite the size of a lot of our HyperVoxels. Now, a really nice thing that we have available is the ability just to change the one specific object and its overall size. Because if we take a look at the objects in the scene right now, we're going to see that there's over 4,000 of these HV clip objects. So rather than having to go in and delete all of those, which would take an extremely long amount of time, we can go back to Modeler, and I'm going to select Shift H for our sizing tool and hold down Control just to size that up, and then we can hit S to save, and then if we switch to layout, now we can see our spheres are a little bit larger. But also keep in mind, we don't need to match it perfectly, because once we render our HyperVoxels, we're not actually going to be filling in all of that area, mainly because of the type of surface we have on our HyperVoxels. But mainly what we're looking for is that interaction, like we can see right now, with objects going between the trees, which is what we want to simulate with our HyperVoxels, but currently we can't because of the way it's rendering. I've also removed all of the objects from our scene that we don't need. And that's pretty much our higher resolution terrain that we had, our wind objects, and anything else except just the main parts of the scene. So we have our camera null, which is controlling the camera shake, the main HV emitter, which is basically a baked particle motion, the view scene itself, and then all of our HV clip spheres that we have. So we're going to go up to our surface editor now, and for our HV clip object, we now need to make this into a more transparent object. And the first thing I want to do is change our color to white. I'm also going to increase our luminosity amount all the way up to 100% and decrease our diffuse down to 0. And this is going to give us an extremely flat white object. What we want to do is create that bit of transparency around the edges of our object, and that way we can have a really nice interaction between those trees once we render out the animation. If I go to Shaders and select Edge Transparency, go to our Edge Transparency, select Transparent, and then our threshold, which one is going to be the max, is the most amount of transparency we can get around the edges. And now if that's not enough, we can also set up a couple of different gradient maps on the transparency channel in order to remove those edges a little bit more. But I'm going to go ahead and just close that out right now. and we need to focus on rendering out the view scene, because right now the view scene is just going to render in color as it normally would. So I'm going to bring this back to frame 0, open up our xStream plugin panel, and go to the view interface. And now within the view interface, I'm going to double click on our main camera, which is going to bring up the advanced camera options. And what we can do is go to post-processing, color correction, turn that on, and set our brightness all the way down to negative 100%, which is going to render out the entire view scene black. So if we switch back into layout, and now bring our slider a little bit more into the animation, and we just want to get to a point where we can see the interaction between these different surfaces. I'm going to go ahead and render out a frame, and then we can take a look at how this is going to turn out. So now we can take a look at the rendered frame, and we can see the nice interaction between these different spheres and our trees in the scene. And we have a little bit of a render error down here where we have just some of the spheres kind of showing through. But since this whole area on the lower right side is going to be black, that is a very easy fix that we can do in post-production, or even directly within Lightwave, just by placing a little bit of a plane that has a black surface on it and rendering that over this. Now these spheres aren't as transparent as they probably should be. Should probably have a little more transparency around the edges. So really that's just kind of playing around with the surface in order to get it to look a little more interesting. What you could also do is add a little bit of a fractal onto the transparency, and then we can have some variation in some of these areas as it's intersecting with the trees. So once all of that is set and ready to go, you can just render this out and the full sequence, and then we'll be able to use this as a clipping map to cut out the areas of the HyperVoxels that aren't working correctly and overlay everything. Another thing to keep in mind is the render quality that we have for this. And we really don't need to have the highest settings for this specific render. You could really use the lowest settings possible. With basically the lowest level of anti-aliasing, you don't need to worry about motion blur, because the effect is so simple and the way it's going to blend together with the main plates of our render. What we can do is add just a little bit of post-process blur within a video editing program or even an image editing program, and that will take care of any of the little flickering that you'll see caused by the low anti-aliasing rate that we have. So once our scene is saved out and we have another copy of this, we can start to take a look at how we're going to be creating our other scenes and our other plates that we need to render out. And basically, the other renders we need to make is we want to have just the view scene itself. So you could render that either directly within View or through xStream, directly through Lightwave. And what we would want is a scene without the spheres in it. So what we can do is go back to a previous version of this scene, because that's really going to be a lot easier than removing all of these spheres. Although if you did not save, what you can easily do is just remove the emitter from our scene. And I'll just go ahead and do that right now, just using the minus key on the keyboard, and clear that from our scene. And now we can see that all of those spheres have disappeared. Even though they're still in our scene, they will not be affecting the animation. And then we would need to go back to our view interface and go to our main camera. We can double click on it. We're going to turn off our post-processing effects. You can also see that I had a very low quality atmosphere turned on and lighting effect, which will also speed up that overall render when we're in Lightwave. I'm going to go back to our atmosphere editor, and we can change that to global illumination, and we start to get back to the look that we had before. And before we render out the background plate, we just need to take a look at a couple of more render settings in order to reduce the flickering effect that can sometimes happen, and the overall anti-aliasing settings so that it doesn't take forever to render. First, what we need to do is just right mouse click on our camera, and we can see that we're set to the final setting. What we want to do is go to our user settings, and under the anti-aliasing option, I'm going to select edit, and we can see we have an option called texture filtering. And what this option will do is sort of blur our textures a little, but not to the point where we're losing quality unless we have too high of a percentage. Now the way this works is if we're at 50%, it is like the effect isn't on at all. And then we move between crisp and smooth, and once we go above 50%, what we're going to notice is the scene really start to kind of blur out. And the recommended setting for this is usually around 30%. And now, object anti-aliasing, we don't need to worry about having that turned on because all of our anti-aliasing will be done within Lightwave and all of the settings that we have for our camera within Lightwave. So once our texture filtering is set, we're going to click OK and OK again. And now we want to go back to the layout interface, and we need to go to our xStream plugin panel and select options. And now underneath the render quality, we want to make sure that we set user settings. By default, this is usually set to automatic, but if we don't have this set to our user settings, then once we render, it's going to revert back to the previous settings that we had, where we won't be able to use that texture filtering option, which is an extremely important setting to have on if you need to reduce that flickering amount. And normally when you just render directly within xStream, you will see a little bit of a flicker, which can be difficult to take care of in post-production. So that will remove the effect entirely just by using that texture filtering and making sure that we have those options set correctly within our panel. So now that is set up, and we can use that as our black backplate. And we really just have one more thing to consider, and that is whether or not we want those HyperVoxels to cast shadows on our scene. Now, the HyperVoxels themselves will not be casting shadows because it will not render correctly. And I've already cleared the spheres out of our scene, so we won't really be able to show it too much. But basically, if we set the surface or the object settings of our first sphere, which we'll just go ahead and take a look at one of those spheres right now, go to our properties, and you want to make sure you do this before you go ahead and link them to all of your particles. You just want to check on unseen by camera. And what that will do is hide that sphere from the scene, but it will still cast shadows on our view scene. So it's a really nice way we could create that plate with the shadows directly on our scene without having to worry about the HyperVoxels using it at all. And all we really need to do is go into our surface editor and turn down or increase the transparency amount to create a lighter shadow. Because of course we wouldn't want something extremely dense and a very dark shadow on this scene because it wouldn't match up correctly. So you increase that amount until you get the look that you need. And the only thing you really have to watch out for then is spheres going through our terrain, which can sometimes cause render errors. But let's go ahead and take a look at a scene now, just to set up the final render with all of our image sequences and kind of combining everything together. And that will include rendering out our HyperVoxels. So I'm going to load in a version now without the removed particles that we have, and then we'll be able to take a look at the scene and modify it a little bit more. And now we have our scene with the particles back in, and we can see those. And what we want to do is go into the view interface, and we're going to completely remove this terrain from the scene. So we can select our procedural terrain, and we're just going to hit delete. And since we painted in these ecosystem objects, we want to pull up the ecosystem painter and just select clear. And now we can see that all of those objects have been removed from the scene. When we go back into the Lightwave interface, we can see that all of that is gone. And we can just see our particles. And now I don't want that sky rendering in the background. But the reason I'm not removing the entire view scene is because we still have the view camera and the view light. They're effectively rendering and lighting the scene. So we can't remove those entirely, but we can make sure they can't render. So we can hit Control and F6 on the keyboard to bring up our effects panel. And we're going to check off xStream and turn on HyperVoxels. And now we're just going to have our HyperVoxels showing up. And if we open up the HyperVoxels interface, go to Viper, you can see the settings I have right now are simulating more of a water effect. And if we go to our shading options, I'm going to increase our density a little. And once we put our backplate render in the background, which will be rendering the HyperVoxels over that so the transparency looks correct, we'll be able to adjust these settings a little bit more in order to get a correct looking overall look to our HyperVoxels. So I'll just close these out right now, and I'm going to load in the image sequences that I have for the background render and also that alpha. And now I have both of our sequences loading in. And I've done just a little bit of post-production on these, just to speed up render times, where I've just done a little bit of post-process blur, and that way I didn't have to render out as large of a frame. But of course that's really not something that's entirely workable for production. It's just something I've done for the tutorial, just to speed it up for me. And we can scrub through the alpha that was rendered, and we can see that nice interaction between those spheres and how they come through the trees and block everything out. And if we take a look at the back sequence, which is just the trees themselves, no shadows in this case, although we could have rendered shadows, but I chose not to, just to speed up render times. And we've got that little bit of a motion blur in there as well. But now what we can do is set up our scene to render this out correctly. And what I want to do is hit Control and F7, and that's going to bring up our compositing panel, which is under the effects. And for our background image, we're going to select that back that we had rendered. That's just our view scene. Our foreground image is going to be the exact same, and the alpha is going to be that alpha sequence that we had rendered. And now there's two ways we can do this. The way I have set up here will automatically take everything with the HyperVoxels and render it all together at once. But what I would really recommend doing is first not using the foreground, and that way we can just render out the HyperVoxels by themselves and then cut them out later in a separate scene. And the reason we do that is because if there's a problem with our foreground image in alpha, then we don't have to re-render out that HyperVoxel scene. We really only need to modify the clip sequence render, which is going to be an extremely quick render, which will also be turning on the foreground fader alpha for. And whether or not we need to invert this, we basically have to wait and see when that render is done. So I'm going to select none right now for our foreground image and alpha, and we're going to open up Viper and just take a look at our HyperVoxels with this plate. We can go back and load that up. And we will just need to render out a frame first in order to get that background to show up, so that we can see it within the Viper and interacting with the HyperVoxels without having to do any large renders or anything that's going to take a really long time. So I could just go ahead and render out a frame really quick, and that will refresh the HyperVoxels Viper preview. And one thing to keep in mind is you will not need to render a complete frame in order for this to update. You really only need to just render frame just to trigger that, and then you can just abort it, escape, and then you'll be able to see that within Viper. And we can scrub through the animation a little bit more, and that will update our image in the background. But we can really see now the hypervoxels and the overall transparency, because right now we can see the plants through them, which is kind of what we want, but they're a little dark, and for simulating something like water, we would need to increase some of these different settings. So I'm going to increase our luminosity value, and we can see that showing up. It looks a little bit better. And we could also increase the density amount, thicken it up a little, and now we can see we have a very dense object. And overall it looks pretty good. And another thing we want to keep in mind is that if we take a look at the bottom part of our frame, and basically where all the hypervoxels are starting, all of that is going to be cut off by our clip map, and all of our objects from the view scene being hidden by a terrain. So we don't really need to render those. So what we want to do is use a dissolve effect based on the lifetime of our particles, and that way we won't be rendering that back section, which will incredibly speed up our render times. So we can go to our dissolve, hit T for our texture, change this to a gradient, and we want to set this to relative particle age, because we don't want to base it entirely on time. We do want it to be almost directly connected to the particles. And now I'm going to create another key at the bottom, and then the top one I'm going to reduce our value down to 0%. And we can see that now it's rendering the back and not the front. So I will invert as if we just made the bottom key that reduced dissolve effect. And now we don't see any of that bottom part really rendering. Of course, we've got a gradient that's kind of showing up from that dissolve effect. So what we'd want is something a little more harsh of a cutoff. So I'm going to click in here to create another key, set that value to 100, and then go down to the bottom and set that value to 0. And now I can pull up the 0 amount. And that's just because we want this to just cut off right away. We really don't want too much of a blend. And we just want to move that key up to the point where it looks like it should be good, without rendering too much of unneeded hypervoxels. And now we can see that cutting away. And now we're only really going to be rendering what we need. And that will definitely increase your render times, because hypervoxels can take a little bit longer than most effects to render. And really depending on the motion blur settings that you have and the overall qualities of your anti-aliasing. And of course, for the best effect, you're going to want to make sure you have the volumetric anti-aliasing on. So go ahead and click Use Texture. And now basically we can render out this scene and use this as our new backplate. And then we can composite together with our clip map and the original backplate without the hypervoxels, and we'll be able to see the completed scene. So if we go back to our camera properties, and we just want to pull up our panel for this. Right now we're using the advanced camera, and I just have all of the default settings. I'm also using a fairly low resolution, only 800 by 450. But if we take a look at the anti-aliasing settings, I can really turn that down to about 2. And if we're going to be using motion blur, one of the nice things about the advanced camera is we can set this to photoreal. Now there's a huge difference between render times once we go past the number of 2 with either of these options. So if I set motion blur passes to 2 and our anti-aliasing to 2, the render times won't be too bad. I could also set our anti-aliasing to 1 and our motion blur passes to 3, and that really won't be all that bad. But once we have a number that equals greater than 4 between the two of these, we're going to notice a huge increase in render times. So it's really something you need to adjust depending on the size of your scene. Motion blur passes, if you're going to be using the photoreal motion blur, you're going to want to make sure that you have at least 2 set for that. I would recommend a level of 3 or 4, but of course that will increase your overall render time by quite a large amount depending on what your anti-aliasing settings are set to. And depending really what you have in your scene while you're rendering will of course also affect these different settings and what you really need to use. So the best thing to do is just kind of render out a couple of tests with different settings, maybe at a lower resolution, to figure out what the overall blur length you'll need and anti-aliasing settings. Of course with a couple of frames as well, individual frames, just to check that against render times and quality in order to get what you need in order to make the scene look correct. So we can go ahead and render this out, and then we're going to load in all of the new image sequences, and we can take a look at setting up the scene. So I'm going to go ahead and clear this out, and then we can take a look at putting it all together. And now I've just loaded in all of our different sequences, and if we take a look at the HyperVoxels render, we can see that we're starting at a much later frame, where I've actually started the animation at frame 45, and that's because we don't need to render anything before that, because we're not really going to see those HyperVoxels showing up at all, and it's really not all that important to have the earlier frames in the scene. And it goes the same way with that alpha that we had created, because all the beginning frames are black up until we reach the point where it just starts to peek through. So what you can do is skip rendering all those different frames and just insert in a black frame and give it the names to match up with your sequence, and then that'll work out correctly. So let's go ahead and take a look at our camera settings. Just select our camera, bring up properties, and I just want to change this to a HD setting. Of course that's a little bit higher than our overall render, but we can turn down the multiplier just so we can work with this and see it a little bit better, because I did not render this out at the largest quality. It's actually a little bit smaller, and we can see that some of these have a fairly low pixel amount. Anti-aliasing we can leave off completely. Motion blur we do not need on, and we can also stick with the classic camera. Unless you're going to be rendering only on one system without a render farm and you have multiple cores, then you want to make sure you're using the advanced camera, because otherwise you'll have a huge slowdown in your overall render. So we can hit Control F7 to bring up our effects panel. And for our background image, we're going to be selecting that original backplate we had. Foreground is going to be our new HyperVoxels, and then the alpha is going to be the alpha we had set up before. We want to turn on the foreground fader alpha so that it's going to show up, increase our frame rate to 120, which is the effective range that we have. And now if we just kind of scrub through, we can see all of our different plates moving. And let's go ahead and render out a frame and just take a look at that. And now because of the enlargement, of course we're going to see a little bit of blurring in the overall scene, but we can see that nice interaction between our trees and HyperVoxels that we wouldn't normally get because of the HyperVoxels overlaying. So it's a really easy fix that we have just by using that alpha trick that I showed you. I'm going to go ahead and render another frame a little bit earlier in the animation. And now you're also seeing a bit more blur around the HyperVoxels, and that's because I did some post-processing with the HyperVoxels just to speed up the render, and I blurred them out. And since our spheres are a little bit larger than the HyperVoxels, that area is being cut out first. Now in this case, what I could do is actually swap these different sequences where I put the HyperVoxels in the background, and the foreground will be the main backplate. And in that case, we'd have to go to our alpha sequence, go to editing, select invert, and I'm going to render this out again. And now we can see that has been reduced just a little, but overall we're getting the same sort of an effect. If we go a little bit later into the animation, we can see the nice interaction between this tree on the left, also with our mountains, and how it's just kind of flowing through. So you can render this out now extremely quickly. Since all of the images are already rendered, you just need to place one over the other. You can see right now I'm rendering real time, and this is taking under a second to complete. And we can just see all of those different effects showing up. So I'm going to load in the finished render and just put it as a background, and just kind of scrub through it, and we can take a look at that final image. And now I've just set our background image to that final render. And if we go to our display options, I'm going to set our camera view background to preview or background image. We'll be able to see the render show up, and I use D on the keyboard to bring up our display options. And now what we can do is scrub through the animation, and we can see all of those particles coming through, and the HyperVoxels with a really nice interaction between our trees. Of course, the quality I have for this is not going to be the highest, mainly just because of production times. But you get a really good idea of what you can do with this technique. Because we can see right here, just as this water starts quickly flowing through, we have a really nice interaction with everything, and it does look really, really good, and it looks as if it was rendered together and not necessarily something that was post. So if you take a look on the CD, there's also a movie of this animation that you'll be able to take a look at in real time. And I hope that this tutorial has helped you kind of get through any of the production problems that you might have been having between these two programs and using and creating this sort of an effect.